discuss the answers for the model question paper for module 1 for the subject code BDS306B Python programming for data science. So the first question 1A is brief out the different features of Python programming language. This is for 10 marks. So these are some of the important points that you need to write, and whatever you write, please highlight them. So what I have written, I have put some of the points in bold, so that means you need to underline them in the answer script. So first point is you have to say now Python is open source, it's a high level language, interpreted general purpose dynamic programming language. It's relatively easy to pick up and use, we know that, right? And extensive libraries, right? So Python is known for its extensive libraries. It is backed by large community of developers. It has a huge comprehensive library with there's something called as Python package index, PYPI, which we call it as, where it lists all the package libraries and we can easily download it as PYPI. And the fourth point, flexibility as a programming language. Why do we say flexible is we can use an add-on to make highly customized programs, and it's widely used in complex scientific computations. And it's a cross-platform language. That means Python is not platform dependent, it's an independent portable language. We can easily incorporate C, C++ functions and data types here. Software quality also, it's very good in the sense it's easily readable, coherence and quality. It has advanced features also like generators, comprehensions, and overall it's a very versatile language. And the data types are also strong and dynamically typed. In the sense we do not have to type the data types. Whenever we declare variables, we never say, unlike in C, int C, float F, right? So Python is dynamically typed. And it's embedded easily into any applications to provide a programmable interface. Python programmers, they use scripting to automate the daily tasks, server management, social media management, financial training, automating software. So various applications are there. And also it's very developer productivity increases because of the small size. It runs faster. We have less code to maintain, debug, less compilation and linkage steps. So, and also Python has a rapid edit test debug cycle, and it has lack of compilation steps, right? Very less compilation steps, which makes the development and debugging much more efficient. And hence it's very beneficial for web scraping, website creation, data analysis, GUI development and game development. So all these points, at least some 8 points of this you should remember and write for 10 marks. And you should expand. Just writing the headers will not count. You need to expand and express each point. The next question is again for 10 marks. Describe the different data types available in Python. So first of all, we have learned in the sessions, right? First, how do you check the data type? So that you write. We can set the data type just by saying type. If I say type 7, then it will give the answer as class int. So any variable, any number, any value, you can change the data type by just putting that within type and parenthesis. So what are the different data types? Before you start writing, you first put this diagram. So the diagram is data types. Different types are numbers, boolean, none, sequence data type, set, frozen set, mapping type, dictionaries. So under sequence you have strings, list and tuples. So in this question, since it's for 10 marks, we are just going to explain all the basic data types, and we'll just give a description of what is a string, list and tuples. So first say what is integer. As we know, it's a primary data type. It can have positive, negative number. Give some examples of decimal integers with the base 10. Give some example of octal integers, right? How do you recognize? Either it starts with 0 followed by a big O or small o. Hexadecimal integers, how do you identify them? Starts with a 0 followed by a small or a big X. And integers also can be of any length. It's not limited by physical memory. So that's the first data type. The second data type is floating point numbers. Basically they are fractional numbers with decimal point. It can be positive or negative. Give an example like this. Here also size is unlimited depending upon the range of the machine. Then the third one is a complex number. It's an extension of floating point numbers where you have real and imaginary part, and hence it's heavily used in scientific domain. How do you represent a complex number in your program is, if you just write complex within parentheses 3, 4, you will see that the output 3 plus 4J. will be displayed, where 3 is the real part and 4 is the imaginary part. You can also write like this. You can also say C is equal to 3 plus 8j. And if you just ask what is C dot real, it will recognize that 3 is the real and it will give the output as 3.0. If you say C dot image, it will give out the imaginary part. So you have to give this example. And you also have to tell first what is a data type, right? So a data type indicates what values the variables can hold, and an operator can hold, and an operator indicates the kind of operations performed on the values. So if you just say the first one, it's enough. Data type will tell what value a variable can hold. And as you saw, Python is supporting a numbers and floating point numbers, and this is a classification. Now you also have to explain just a few of them, like Boolean types. Boolean is also another data type. It's also called as bool, where it basically refers to true or false or integer 0 or 1. Give two examples, right? If I have a variable, let's say time underscore up is one variable is equal to true, and if you try to display that, true will be displayed on the screen. If you say bool of 1, right, and you try to see the output, true will come in that place. And if I say bool, this is a string, yes, true will come, because this is actually a string. That's why true is returned, right? So Boolean data types will either return a true or a false or integer 0 or 1. So you have to give 2 or 3 examples. None. See, none is a special data type again. Basically, it has no value. In other programming languages, we also have it, which is called as null. Similar to that, this is. So if I actually go to my Python editor and say type of none, it will say class none type. So that means what? None is also a not having any value, is also having a data type, and that is called as none type, right? So NaN, in one of the sessions I've told, it is also it is the only one which is having a data type as none type. And if it will return a value, so if you ask, it will have a return value of function is default. Return value of any function is none. So if you write a function and you do not specify any return value, then its default value will be none. So that means no value. It doesn't even mean 0. No value, that's all. And you also have some thing called as collection data types. Collection data types, basically they have two types here, right? One is sequence and the other one is mapping. So sequence is an order collection of values, for example, like strings, lists, and tuples. So just give a brief description of each of these three, right? So string is actually a sequence of characters. Example, name 1. You can see this is a sequence of characters. List is a sequence of values. So when you're writing a list, remember, put it in a square brackets, and it can have anything. It can have floating point numbers, integers, strings separated by commas. Tuple is also a sequence of values like quest, but the only difference is it's immutable, right? And it is enclosed within parentheses. So put parentheses within that. Again, you can write strings, integers, or floating points. So that's enough for data types. If you write this much, it's enough. But very important, you write the chart. This chart, this will have some marks, and everything should be explained with examples. Now coming to the next question, which this is question 2a. With suitable examples, illustrate the formatting of the output using print method. Right? Now what is this question about? See, basically this question is about how you can do formattings, right? Many times simple printing of values is not sufficient, right? Many projects will require fancy printing as per the requirements. So that is called as formatting. So all variables and constants, they need to be converted to a string type for printing purposes. So some of the string formatting methods, you have to write 4 methods here. There are 4 types of string formatting methods. First one is built-in method. Second one is string interpolation. Third one is formatted string literals, and D is string formatting. You have to write all the 4. And before you start, you write off this table. Right? What is this table? This table is for the first one, where first method, what is it saying? Built-in methods. There are some built-in methods, right, which actually start with slash, and it will do some kind of formatting, right? So // or slash with a double quote, /a. You can try all this in your Jupyter notebook or whichever IDE you are having, right? So just give some 3 or 4 examples here, right? // double quote, ASCII bell, just 3 or 4 for each table. If you write, it's sufficient. The next one is string interpolation. Now string interpolation is a way of combining the strings with the constants or variables to create a user specified output. And here this what I'll be talking about placeholders. Placeholders are nothing but replacement. Okay, so some examples of this are %C. If I say, basically it's a conversion to character. %S, if I say it's string conversion. %DI, if I say signed decimal integer. %D, I say it's signed decimal integer again. %U, I say it's unsigned decimal integer. %O, octal integer. So at least some of them you have to write. Okay, and so basically percentage is an operator that replaces this placeholders, and it's used for formatting the string. So what is the syntax? Syntax is like this: format, percentage, and then you have to give the value. Okay, this is the syntax. So let's see an example to understand this. Let's see this formatting string literals first. See, in formatting string literals, there's some in this we use something. We do formatting using the capital letter F or small f. So F strings are string literals that start with capital F or small f. And you have curly braces. Curly braces are basically the placeholders that will hold the expressions that are replaced by the values. So Python F strings make string formatting more readable and more concise. So %f formatting is specifically used for formatting the float values. So it specifies the number of decimal numbers to be returned when a floating point number is rounded off. So what do I mean by this? Suppose in my editor I just Python IDLE screen or Jupyter Notebook, just put this. Some variable is equal to 1.9876. These are the things I've got from I've executed and put in this presentation. So if I take a variable, I make it equal to 1.9876, and while printing I say %f %f within double quotes, then I say %float number. What happens is when you get the output, you get something like this. So what's the difference? 2 zeros are getting added at the end. Okay, so now the same for the same value 1.9876, I said %.1f. That's the only difference I made from here to here. So then what happened is I got an output like this, 2.0. So basically what happened, the number got rounded up to 1 decimal place. Rounding up happened. Now for the same number 1.9876, if I say %.2f, I just changed 0.1f to 0.2f, then what happened is it's rounding up to 2 decimal places now. Okay, that's the difference. So when I say 0.1f, it's rounding up to 1 decimal place. When I say 0.2f, it's rounding up to 2 decimal places. So basically these examples are showing us, right, how rounding up can be done or string interpolation happens. Now coming to the last formatting method, that's called a string formatting. Now here there will be a format between the strings and the arguments. See, let's see, this is a syntax. In the format, now I will write value and specifications. So if you see the example, you will understand. See, I've given a value something like this, and what am I saying here? Format, within that I'm giving that value val, comma 0.3f. So now what it is doing is it's printing up to 3 decimals. See, this is the output I got. So now in the second one I'm saying val 3.2e. So basically what it is doing, it is giving the output in a scientific form. 1.23 up to 2 decimal places only, then e plus 0.1. The last one, if I say capital E, it is saying 1.23 capital E plus 0.1. So this is the scientific form. The first one is rounding off to 3 decimals. That's the difference. Now second example, I have a student called as name1. I have the student here 2022. I have a variable called as register number is equal to some number. So what I have done is I'm trying to print the value. How am I doing is I'm putting curly braces dot, basically that would be the, what is curly braces? I said it's a placeholder. Okay, dot register number, again curly braces, comma study year is again curly braces. And here what value I'm passing is dot format. Under that I'm giving 3 arguments: student, register number, student study year. So what happened is in the first placeholder the student name goes. So student name is name1. In the second placeholder register number goes. And in the third placeholder, this is a placeholder, there the study year comes. So what is the final output I am getting is name1 dot register number, then you get this number, comma study year is 2022. Now suppose I just if you see this, I just make it ulta, right? I just change 0 with 1, right? Then what happens is you see the output. Name replaces argument 0 and is replaced. So you try these examples, right? And you just try to change these arguments, the sequence, and you can see that the arguments, when you change, the output will also change. Okay, just put register number before, put student later, right? So basically this is an example of string formatting. The next question, so in the previous question, just to revise, this was a turn marks question. So you have to write all the 4 methods to get full marks, right? Built-in method, string interpolation, C is a formatted string literals, third one was a string formatting. And you have to write this table. If not for every point, at least you put some 2 or 3 things under each table. Okay. So coming to the last question, give the importance of operator precedence and associativity rule, and they have given an expression to evaluate. Okay. So first of all, what is operator precedence? If there is one expression with more than one operator with different precedences, so operator precedence is the way the operations are carried out. Okay. And operator associativity, if an expression has two or more operators with the same precedence, then how associativity comes. Okay, then associativity comes into picture. So there are two types here: left to right associativity, right to left associativity. So basically all the expressions by default, they will be associated left to right except for the exponential. Okay, so let's see an example. So basically what rule is being followed is this table you have to write. This is the order. This table shows the order of precedence of the operators, and the lower one is the lowest precedence and it goes up a highest precedence. So plus and minus is having the lowest precedence. Slash, double slash, multiplication, percentage has the next. Then you have unary operators, then exponential, then parenthesis. So basically parenthesis will be evaluated first, then exponential will be evaluated, then unary operators will be evaluated, then division, double backslash. See, basically that means that is called as floor division. Okay, the multiplication, and finally addition and subtraction is normally done. So you have to remember this order in order to, this is a very common question. They will give you an expression, you have to evaluate, so you have to remember this table. So since the question is also asked as a theory, you have to write this table completely. Okay, so this rule is actually called as Pedmer's rule, right? Because P is for parenthesis, E is for exponential, the next is comes multiplication, division, addition and subtraction. So it's called as Pedmer's rule. So and also you go through this, right? I am sharing this. So they have given this question, they have given values for A, B, C, D. They have given two expressions, A plus B double star. This double star, this asterisk is nothing but exponentiation. Okay, then you have C double slash D. So this is nothing but floor division. Floor division means it's basically division will be performed, but okay, but the numbers after the decimal point will be okay. So the numbers after the decimal point will be neglected. So that is called as floor division. Floor division means, for example, 12 floor division 10 means the quotient will be actually 1.2, but answer only 1 will come. So that means the numbers after decimal point is ignored. So this is the answer. Just try out this in your system, and any doubts just let me know, okay, in the comment box. So just a quick revision. We just saw in this session the module, discuss the answers for the module question paper, features of Python programming, different data types we discussed. We discussed the different formatting outputs using print methods, and we also saw operator precedence associative rule with the expressions. So thank you. Any doubts just let me know in the comment box, and please subscribe to our channel. Thank you.